for today is circular orbits relate Kepler's third law of planetary motion to Newton's law of gravitational and centripetal acceleration. Let's talk about the Kepler's third law. So Kepler's third law states that the square of the orbital period of a planet is proportional to the cube, the semi-major axis of its orbit. For a circular orbit, the semi-major axis is simply the radius of the circle. So we have Kepler's third law formula, which is the t squared equals 4 pi squared over r cubed and gm. So the t represents the orbital period, the r is orbital radius for circular, a is semi-major axis for elliptical, while the m mass of central body. Let's talk about the Newton's law of gravitation. Newton's law of universal gravitation states that the gravitational force between two objects is proportional to the product of the masses and the inversely proportion to the square of the distance between them. So we have the formula of Newton's law of gravitation, which is the F equals G big M small m over r squared. So F gravitational force, while the m1, m2 or m and m interacting masses, r distance between their centers, while the g is equals to 6.67 times 10. Let's talk about the centripetal acceleration. An object moving in a circle experiences centripetal acceleration directed towards the center of the circle. This acceleration is given by AC equals r over v2, where v is the orbital velocity. So we have this formula of centripetal acceleration, which is the AC equals v2 over r, and we have the r equals 4 pi squared r over t squared, and AC equals f over m, and gm over r squared. So v represents the orbital speed, while the r radius of circular path, w is the angular velocity, and its formula is w equals 2 pi over t, and while the t is the period of revolution. So we have the example here, Earth orbiting the Sun. So we have the mass of the Sun, which is 1.99 times 10 with the highest power of 30 kilogram. The mass of the Earth is 5.97 times 10 with the highest power of 24 kilogram. And the distance or average radius is 1.50 times 10 with the highest power of 11 m. And we have our g, which is 6.67 times 10 with the highest power of 11 n. So in solving this, we're going to use the formula gmm over r squared. So first we have our g, which is 6.67 times 10 with the highest power of 11. And we have our m, which is 1.99 times 10. And we have this mass of Earth, which is 5.97 times 10 with the highest power of 24. And we have this distance, which is the 1.50 times 10 with the highest power of 11, then squared. So we're going to multiply those numbers, and it results with 3.5 times 10, 22 neutrons. So this is the gravitational force keeping Earth in an orbit. We have the example of centripetal acceleration. We're going to use the AC equals F over m equals gm over r squared. So we're going to use those numbers earlier, which is 6.67 times 10 with the highest power of negative 11 times 1.99 times 10 with the highest power of 30, and 1.50 times 10 with the highest power of 24 squared. So in result, we have the AC equals 0.006 m squared. So it's the accelerations toward the sun of about 6 meters per second. Thank you for watching.